So today we are finding the volume of pyramids. So if you look at this picture, to show you where the formula comes from, notice that it's very, very close to the volume of a prism. So it's area of the base times the height. But you have to divide that by 3 or multiply by 1/3. So another way you could write this is area of the base times the height, all divided by 3. And you may think like, well, where does that 3 come from? Like, why are you dividing by 3? Here's where you can see that picture. So you can see a little bit more better, or a little better with your with the colors, whereas on your note sheet it's a little harder to see since it's in black and white. But notice how like a triangular prism they have here, do you see how it is really 3 pyramids together? So the green one is kind of in the back, and maybe the orange one is probably the easiest one to see up front. But a triangular prism is made up of 3 pyramids. So the formula comes from the fact that 3 of these pyramids fit in a prism. So if you want to find one pyramid of a prism, you have to take the volume of it, of that prism, and divide it by 3. So that's where the 1/3 or the divide by 3 part of the formula comes from. So for the first problem, we defined the area of the base. Okay? So the base is a trapezoid. So you remember that formula? The formula for the trapezoid is 1/2 the height times the sum of the bases. So I take 1/2, or I'm going to write it over here. So 1/2 the height. Now the height of the base, not the height of the pyramid. So the height of the base, if I'm just looking at the trapezoid, is 2. And then the 2 bases, so the 2 parallel sides, are 14 and 5. So then when I add, or I figure all that out, so 14 plus 5, and then times 2 times 1/2, you get 19 feet squared. Now for volume, I want the height, not the slant height of the pyramid. So this 9 feet is exactly what I need. It's perpendicular to the base, so I'm going to write 9 feet. So what I'm going to do is I'm going to multiply the area of the base times the height, and please, please, please do not forget to divide this all by 3. So what I end up getting is 57 feet cubed as my answer for the volume. To amp it up a little bit is when you get a more complicated base. So everyone's favorite, it's a hexagon. So the formula for a hexagon is 1/2 AP. And of course, they don't give us everything, so I'm going to have to figure out how to get my apothem and my perimeter and all that jazz. So I'm just going to draw that base over. And I see that it's 22 inches here. And I'm going to need my apothem, so I'm just going to draw that in by myself. So for my apothem, that's what I need first, is my A. This is a 30, 60, 90, because if I take 360 divided by the number of sides, I get 60 degrees. And then I take 60 degrees and cut it in half, so remember that's a 30 degree angle there. So I can use my special right triangle rules. So I'm going to cut 22 in half to get 11. And then remember, I multiply the short leg by radical 3 to get the apothem. So this would be 11 radical 3. And then for my perimeter, to find the perimeter of the base, I take 22 times the 6 sides. So that's 132. then I get that. And when I multiply that, I get 1,257.5 inches squared. And then the height of my pyramid they give me as well is 42 inches. So I'm going to take those two numbers and multiply them. And I will not forget to divide that by 3. So I get 17,605 cubic inches as my volume. Next one, pyramid. So I need the base, and the base is a square. That one is probably my favorite because that's just a side squared. So I just have to take 6 and square it. So I don't even need a calculator, I just do that in my head. It's 36 centimeters squared. And I'm like, height. Oh, okay, 12. No, it's not 12. That's the slant height, not the actual height. So you have to draw in your own H. And whenever you don't know a length, you always want to look for right triangles. Okay, so what I like to do is redraw the right triangle. So this is 12, so that's this part of it. This is my height. And then the shorter part of that is, if you look at it in this 3 dimension, that's like halfway across this length. So that's going to be 3. So what I'm going to do is I'm going to use Pythagorean theorem. So I'm going to use Pythagorean theorem and do h squared plus 3 squared equals 12 squared. So then what I get for h is the square root of 135 when I solve that. So when I find the volume, I'm going to take 36 times the square root of 135, and then I'm going to divide that whole thing by 3. So my volume is 139.4 centimeters. Okay, here's a little algebra, fun stuff. So I need to find the unknown edge. So the volume formula for a pyramid is area of the base times the height, all divided by 3. So they give me volume is 120. So I'm just going to replace the V with 120. And then I'm going to keep the 3. And I have area of the base. So big B represents area of the base. So to find the area of the base is a square because all the sides are the same, and then there's right angles. So I'm going to take this side and square it. So then that's pretty much done. So I have x squared, and then my height they give me is 10. So this is our setup. So now we need to solve for x squared. So for me, I like to have the coefficient in front of x squared before I start solving, just because that's what I'm used to. So I just switch around the 10 and the x squared by commutative property, totally legal to do. And my first step with solving is I like to divide off that fraction. So this 10x squared is all being divided by 3. So what I'm going to do is multiply both sides of the equation by 3, because what will happen is these will divide out. This is this giant 1. So what will happen is I'll have 360, so 3 times 120, equals 10x squared. And I no longer have a fraction that I have to work with in my problem. So next I need to get x squared alone, so I'm going to divide both sides by 10. I'm left with 36 equals x squared. And to get x alone, I'm going to square root both sides. And because we're talking about a length, this is only positive 6, not negative 6. And that is now the answer to the problem. Now the last problem is a composite figure. So think of this as like the little divot at the bottom of like a water bottle. So this is the airspace, the pyramid is. So what I'm going to do is I'm going to find the volume of this entire prism, and I'm going to subtract out the pyramid, the volume of the pyramid. So the volume of a prism, the formula is area of the base times the height. So to find the area of the base is 8.4 times 12.5. So that's the base part of it. And then the height is 20. So when I multiply all those together, I get 2,100 meters cubed. And like I said before, now I'm going to find the volume of the pyramid. So the volume of the pyramid is very similar to the volume of a prism, only you cannot forget to divide by 3. So I'm going to find the area of the base, which is the same as the other one. So I'm going to go 8.4 times 12.5. So 5. And then I need to multiply that by the height. So the height of the pyramid is 7.3. And then I have to divide all that by 3 at the end. So when I type all that out, I get 255.5 meters cubed. So now to find the volume of the solid, I'm going to take the 2,100 and subtract out the 255.5. Get a grand total of 1,844.5 meters cubed. And that is pyramids.